So good afternoon, class. Once again, in this course, I'm gonna do the next chapter in our syllabus, which is the system architecture chapter. We're gonna talk about this chapter today, and I will also explain the second project to you, which is gonna be your final project for this course. And there is still a 50% left even after you complete all the projects, and that will be a subject we need to discuss today as well. So quite a lot of things that we need to cover. First thing first, I have decided to reduce the number of courses into once a week. There are plenty reasons for that. First of all, we are approaching to the end of the term now. We only have like 2 weeks left, and I mostly finished all of my classes. It's just after this we have one more chapter, and that's it. That's going to be the end of the curriculum that we need to cover. And so far, I have realized that many of the lecturers, they haven't actually followed their timetable, and I did this. So every single week, every Tuesday and Wednesday, I connected. So that actually boosted how fast I went throughout the course. And I managed to finish, because of the lack of practical sessions, I managed to finish much faster. In a classroom environment, these topics should be more discussed as we move from one topic to the other. Unfortunately, because of the nature of the environment that we are doing the lectures right now, that is being me talking and you just listening, and minimal communication is happening throughout the course. The course turned out to be not very much interactive, not as much as in the classroom environment anyway. So this resulted me to go much faster than usual, and hence why I decided to reduce the courses to once a week, which means that 2 more chapters and we'll be done. The next thing I like to discuss is the project section that I uploaded yesterday. You might have realized that you have a new project now under the project section. So you can see your project, the coursework over there. So let me just change my status to student so I can see exactly like you do, because I have several, as you can see, hidden layers that I see. So I'm going to change myself to a student. So I will see exactly like how you see this page. So if you browse down into the project sections, you will see that there is the coursework 2 now being uploaded. That is something we need to discuss today. So let's go through this project. In the second project, what you're going to do is very much related to what you did in the first one. So basically, you're going to do a reverse engineering process, something that we discussed throughout the course. And using that reverse engineering, you're going to work on the same project with the same people, but this time with a completely different aspect. So let's go through it. This project is given to you by 12th of May, which is today, and you're going to do a submission in 3 weeks, which is the 2nd of June. And the submission will be just as like the first one. You're going to do a submission as a PDF file, and it should not exceed 32 megabytes. This time you're not going to develop software. It's just going to be a report, an online report. And using that online report, what you're going to develop is that you're going to upload an individual evaluation sheet of the overall performance of your peers and yourself as well. And you're going to upload several documentations regarding UML. Like the first assignment, this assignment is also a team project, so you are not going to do it alone. You will actually work with the same people, same team that you were assigned in project 1. So you're not allowed to change your team, because you're basically going to reverse engineer the same project that you have done in the first one. Okay, and if you didn't, then you will assume that the project is successfully completed, and you're going to reverse engineer, assumingly the successful version of the project. You need to generate a software design documentation for project one that you completed. And this design documentation will include UML specification diagrams as well as a Gantt chart that shows task duration, milestones, and a section that shows who had worked on which part in the project. So basically, two documentations are being uploaded. Everyone will upload an individual appraisal, and one of your team members, one of the team leader perhaps, he or she is going to upload the teamwork. So there are two uploads you need to do. One is called an individual appraisal, which means you evaluate how well things gone with the team and what else you could have done differently. And the second one is basically the actual specification document. You need to submit an individual evaluation form that shall evaluate your own and your team members' performance in the project, and this submission will be confidential, which means I'm not going to share it with anyone. I'm not going to basically, assuming that Daniel is working with James, I'm not going to share what James written about Daniel or vice versa. The project aims to practice UML specification document and project scheduling, such as the Gantt chart, something that we covered throughout the course. Now you're going to draw it for yourself. Previously, you submitted a GitHub assignment, which included the construction of a software using Git and other services. During this development, you were not asked to do any modeling documentation because you were using the agile development. In this one, however, you're going to reverse engineer, and I want to reverse engineer maybe 10 times. Underline it because you need to understand how reverse engineer is done in order to do this project. So perhaps I should underline this word several times to emphasize its importance. The project you completed in terms of modeling and generate UML specification, requirements, and project scheduling. So what you're going to do is project scheduling, a requirements list, and UML specification based on the reverse engineered version of the project you already completed. You need to draw activity diagrams, use case diagram, sequence diagram, class diagram for the project you already completed and submitted. The numbers are already given to you. Last week, then you'll ask, how many of them do we have to do? Well, this week you have the numbers. At least 3 non-functional requirements, each one that should address the goal of the system. At least 8 functional requirements, each one should be tied to a non-functional requirement. So these do not pop up out of thin air. They actually come from non-functional requirements. So there should be an obvious link in between the two. There should be at least 2 activity diagrams that show the data flow in the system. 1 use case diagram at least, which means you can have more, but there should be at least 1. That will have the functional requirements. It will show the non-functional requirements of the system. So based on the functional requirements that you already defined, this is the visual representation of how we're going to achieve that. And 3 sequence diagrams, which will break down the use cases even further, that will help the developers. So everything that you write in here is broken down. Non-functional requirements is broken down to functional requirements. Each use case is a non-functional requirement, but in between the use cases, there are 8 functional requirements. So when you draw the use case diagram, I will look at the functional requirements. If there is no link in between and you just made them out of thin air, this means you did a very bad design. Hence, you will lose points. So basically, everything should work with one another and it will basically be connected. So although these are different diagrams, they all have a big connection and you must keep them consistent, one basically being derived by another inside your documentation. You will also have 4 class diagrams that shows the structure of the system. You know how to draw the class diagrams because You all have taken object-oriented programming from me, and I teach class diagrams in that specific lecture. You will draw a Gantt chart, which is something that we already showed. And finally, an individual performance report, which is going to be only one page that shows clear division among team members, who have done what, who was responsible, and so forth. I might upload a project format for you so that you can be easy. It could be a consistent format for everyone within this week, so you can see how these can be done and so forth. If you want to go over the board above and beyond, you can include a state machine diagram if possible, of course, to your system. This is obviously extra work and optional. A flow chart that shows solution to problems you encountered, and an activity network diagram that support the Gantt chart. An activity network diagram is something that we draw. In this course, we drew it with using Lucid Graph, okay? I do not provide a standard documentation for generating report because assumingly that is part of your research to find whichever specification documentation that you will need. But I will upload a sample if you want to follow it throughout this week or by next week. So you can see how these individual appraisals or the documentation can be written down, okay? You might also want to discuss every single diagram you upload rather than you just uploading the functional requirements. You might want to say something and describe them in a paragraph, and you are welcome to do so. That will be great actually if you provide extra information without going over the board. That will be great to see in your report. So just to summarize, as a team, you need to submit a modeling documentation and a Gantt chart for the project you completed. That's the teamwork. And as an individual, you have to submit a performance evaluation of yourself and team members, which is called an individual appraisal, and this will be confidential. Notice that you are given 3 weeks to complete this assignment and your groups are already defined. You know which team you are in, so you're not going to change it. And you will not do any kind of demonstration or presentation. You just need to upload the report and individual appraisal, and that's it. No defense will be done. The project grading scheme is also being shared to you. These are some of the questions I will look into in your reports, such as, are the requirements well defined? What are the non-functional requirements? How are these divided into functional requirements? And is this done effectively? How many functional requirements are defined? Do they reflect the functionality of the system sufficiently? Is there a Gantt chart that shows a project schedule? How is this divided? Who is doing what part? Which is something I really want to see in Gantt chart, like dividing the task into people, not only to milestones. How are the tasks are managed? Who have done what in this project? Does the documentation reflect UML specifications? Are they well aligned with the requirements? Are the activity diagrams sufficient? What do they reflect on? Do the use case diagrams or diagram, could be only one, truly show the functional requirements? So can I look at the diagram to tell, okay, the use case is the non-functional and the relationships are the functionals? Can I say that? Is it well aligned with the requirements? Is it possible to use the sequence diagrams as a base for developing the system? Do they reflect on sufficient abstract information to benefit the developers? How many class diagrams are presented? Do they realistically reflect the structure of the system? These are the parts that I will look into when grading your report. So I'm giving you these questions in advance so you can basically develop your documentation around these questions. So basically by answering these questions in a UML specification way, you can complete this assignment. Everything we built up so far, everything we had seen in the lectures was leading to this assignment. I think this assignment will teach you quite a lot about design and documentation. So if you happen to get a job in a big company, you will at least be aware of some of the methodologies they are using, or be in a situation that you can easily be adapt to the documentation process and working with others. I think this is one of the most important courses you can ever take in your undergraduate degree. I cannot emphasize how important this course is. This course is about everything on software development apart from the coding. So all the lectures will teach you all these technical capabilities, like you're gonna learn C++, C Sharp, PHP, whatsoever in mobile development, but they never actually teach you how the industry works, how you can work with others, what kind of tools you can use, what is the design equipments or tools that you can use to develop a software, what kind of agreements you need to come up before you actually work with others. These are all the practices you can look into in this course. It is everything about software development apart from coding, and that is, I think, a very, very important thing in the industry right now. So just because you are a good programmer doesn't make you automatically employable. Because if you lack the capability to work with others, if you lack the capability of designing and developing stuff, being open-minded to produce maintainable projects in a team working environment, then many companies will not hire you. No matter how effective you are in coding, if you are not cooperating with others, or if you do not fit into the model of that specific company, the business model, then you will not be a valuable asset to them. And that is something you are learning with this course. So I think this assignment is very beneficial for you to practice all these requirements that we have covered so far, as well as UML specifications. It will also be an opportunity for you to reflect on your agile development that you use in assignment one. So you can go back and compare how a plan-driven approach is broken down compared to an agile one. Now, I talked a lot, and I think the assignment is very clear. But if you have any questions, I would like to give you the chance to talk. Yes, anyone who wants to talk.
Dr. Chan?
Yes.
No, I do not have any questions so because I want to read the document and I came late, by the way.
It's
But
okay.
I just want to say thank you very much, by the way, for the previous lectures even. It helped me a lot, by the way, for even the managing, in group, doing a project with a group. Because usually I used to face a lot of difficulty to do group projects, so many things. So I just want to say thank you, that's all. But for this one, I don't have any questions right now. I might have later, and I'm sorry again, I came late.
It's okay. Look, I am not doing this. I'm going to be completely honest with you, human to human level. Just forget about for a minute that I'm a doctor, I have a PhD, blah, blah, blah. All this stuff doesn't really matter. Half of the time, I don't even remember that I have those qualifications. But I genuinely want you to learn from our experiences so you can move into the industry, because that is where the money is. Like, if I could go back in time, I'll be completely honest with you, I wouldn't do a PhD. Definitely not. Like, if I could go back in time, maybe 10 years or so, I wouldn't actually do a PhD, because a PhD in our field is, unless you're going to be a data scientist, it's kind of like not necessary. I'm not going to say worthless, because I learned quite a lot in my PhD, but I don't see this as a fundamental thing. The money in in our business lies in the industry, not in academy. So I really strongly suggest you to pursue a career in the industry, which you can earn a lot of money and you can actually develop yourself quite a lot. In academy, we are dragged down, unfortunately, by many mundane tasks that we have to deal with on a regular basis, because that is the nature of the job. But so we don't have too much time to develop ourselves and learn new technologies. We can only learn them as we teach the new courses or perhaps undertake a new research. But you have much more opportunity when you go to the industry, so you can grow in your career and also as a person. I think this is why I really want to share my experiences with you in this course. I worked in the industry, but it's not so. My background is basically in academy. I have been a lecturer for the last 13 years. This is going to be my 14th year. So imagine, for the last more than a decade now, I've been working as a lecturer. And if I could, as I said, go back in time, I would definitely not go into the industry, which I could grow in my career much more. And I really encourage you to go to the industry rather than pursuing an academic career. Of course, you can make a master. I strongly suggest it because you don't want to be a team member all the time. You want to grow and become a team leader or a manager, hopefully, or even an executive professional if you can. And that will make me really, really happy to see you to get into somewhere in the business will give me the greatest gift. Hence why I'm trying to share all my experiences here. And one of the things that I realized as I look into jobs in the industry is getting into a very good business that will earn you money and know also your worth is gonna be really, really difficult. It's not easy because it's very competitive. It's incredibly difficult to get a job in big companies, and you need to know quite a lot. Just because you are good in Java or C sharp or whatsoever, you have to be good, obviously, but that's not good enough for them. You have to understand quite a lot of things before you get into that. And we are already teaching you Java, we are already teaching you C sharp, Python, all these languages that are being used in the industry. But what you lack, I think, the most is the base for the experience that you can go over the board and understand how these projects are put together so that you can instantly go into, fit into that specific company. I have been through many different interviews in my life, including Facebook. I have actually been interviewed by Facebook. And I was very close to get into the Facebook, but I lost the very last interview, so they didn't hire me. So I have some experience with the interview processes in the big companies, like including Google and Facebook. And what they do is they put you into a technical assessment, but it's not only the part of the interview. They ask you quite a lot of questions about other stuff, like if you go to an interview, you will obviously pass through a technical exam. But after, if you manage to pass the technical exam, it's not going to be the only thing that they will look into to get you the job. They will look into how well you are familiar with agile development, some of the business models of that specific company, like if you understand from specifications. A lot of things that we covered in this course are actually being asked during the interviews. And I clearly remember one time I showed you a random LinkedIn job vacancy, right? And there you have seen test-driven development, for example. If you don't know what test-driven development is, no matter how good you are in Java, you're not going to get the job because you don't know how they work. And they will tell you that, sorry, but we don't have time to teach you this. We want someone who already is familiar about this so we can take up and train him maybe in 1 month so that he can understand everything and produce our solutions. The companies today work really, really fast in a very fast-paced environment that everything changes so fast. So they don't want to hire someone that they can teach. They want someone who is already familiar, who has the base, so that they can easily show them this is how it works and move on. Okay, that is why this course and doing these assignments is going to benefit you probably the most among the courses that you are taking right now, except perhaps the capstone project. Okay, because that is also a very important topic, your graduation project. So yes, it is important to pay attention to Java. It is important to network because you must have those technical skills. But just because you are good at it, you're not going to get the job. I assure you. There is a very, very technical, competitive environment out there. I lost the Facebook interview because I didn't know how Facebook worked, basically. I had no idea how Facebook worked when I went to the interview, and that cost me losing the job. And I really wanted that job at the time. So that is a big, drawback of me. And what I'm doing in this course is basically, which is very important to come to the classes, that you are listening someone who made a lot of mistakes like me, so you can learn from these mistakes and perhaps not to repeat them. Okay, this is why higher education is ongoing for decades, even though we have YouTube tutorials, even though we have many platforms now that we can support education. I do believe having synchronized sessions is very important because I'm not only telling you, oh, this is functional requirements, this is non-functional requirement, but I'm also sharing my experiences with you so that you can grow as a person. I hope that makes sense. Why I am giving these assignments to you. Very good. So I'm just going to move on. If you have any questions, if you want to say something, I like to listen to your side about these.
Okay. Doctor, I have one question.
Yes,
Uh, you said that you had many interviews with many other companies,
yes,
like the big like Facebook and others. Did
yes.
they told you kind of programming language specific that they want? For example, what kind of thing or what kind of programming language that they want you to know?
Look, Google and Facebook try to keep their interview process like very secret, but it doesn't work actually. If you actually go to YouTube, you will see a lot of tutorials about to train you in the interview processes. At the time, I watched a couple of them before I went to the interviews. Uh, they do ask you technical questions, as I said, not specifically on the programming environment because I didn't apply as a programmer there. I applied as a researcher because I have a PhD. First and foremost, I am a researcher. I'm not a programmer. So that was the job that I applied. They did ask me quite a lot of technical questions about research, but they also asked other things, like really, really things that I wasn't, well prepared at the time, and I couldn't answer them. And I wish I did a better research before going into that interview, because I thought the interview would be just technical questions, and I was wrong. You see, and these people, they're not going to waste your time with you. I assure you that there is a cruel world outside, and the average time an HR person, a human resource person, is gonna look into your CV is 30 seconds. That's it. So all these 4 years that you are doing right now is on a paper 30 seconds, and you only have 30 seconds to impress someone. If you cannot impress them in 30 seconds, it's gone. You lose the job. That's it. That is how cruel our business is if you want to get into a very serious company. Does that make sense?
Yes, sir. Thank
Good.
you.
You're welcome. I am going to stop now because I've been talking quite a lot. I have only 10 minutes left. I want to start this subject, but within this time, if you have any questions, before I move to my subject about the project, about what I describe you and the assignment. Please ask it now because I really don't want to receive emails later on or messages. Oh, can I do this? Can I do that? You know, these are not supposed to be things that you discuss with me on an email. This is why we have the sessions. If you have any questions, please ask it now and do not email me or message me later because this is why we have these sessions. Okay? Any questions, guys? Please ask it. You need to ask it on the because I'm not following the group chat. I have several windows open in front of me. Please raise your hand on the participant panel and talk to me. Yes, Ravant.
Sorry, doctor. But like, if I read the document again later, will you give me a chance to ask you a question at that time?
It's better if you ask these questions during these online sessions because someone else can also have the same problems. Okay, like I have other courses that I teach, like in Introduction to Programming, I have over 300 students. In this course, I have 25 students, which 16 of them are here. In visual programming, I have 78 students. So overall, with the graduation projects, I have over 470 students that I teach. Imagine each and every one of them ask me something on a message or on an email, then for 8 hours every day, I have to reply to emails the same things. And I don't want to do that because the problems that you can have right now can be problems of other people here as well. Like you have a specific problem in your project, maybe Ahmed didn't understand it, or then Daniel, he didn't understand it either, but he's too shy to ask it. So this is why we have these interactive sessions. You are supposed to approach me and ask me questions or create a discussion because this course is revolves around discussions. Okay, so ask it now, please, rather than messaging me later. Oh, can I do this? Can I do that? I would prefer to discuss it online. Yes, Yashar, you have a question, Yashar? You can talk.
I think he have microphone problem.
He has microphone problem. Okay. All right. Let me just see the chat. I haven't looked into the chat part if you have written anything. Okay, Sinan asked a question. Hojam, I couldn't find the group. You said someone is trying to find the group too. How can I contact him? I posted a Moodle entry for this, but so far I think no one posted there. I said post on this form if you are looking for project members. I am not quite sure if anybody posted. As far as I know, nobody replied. So this is why we have this section here. I created section for you guys so that you can participate in here. You can subscribe and participate should you want to. Okay, or you can create your own discussions here. All right, so that is why I had this section. And if you don't have any group, then how did you complete the assignment one? As long as you can communicate to someone in the taking the course and you want to participate, I am sure people can accept you if you are willing to produce work. No one wants to take another mule to the group because this is how most team projects end up among students. Uh, Everyone's supposed to work coordinated. Unfortunately, one person does the job and the rest of them sleeps and then they blame the lecturer. But the lecturer has nothing to do with this if you are disorganized or not. We just try to encourage you to work as teams because software is produced as teamwork. Now I'm going to stop in here if you don't have any questions and re-invite you again because I run out of my 40-minute session.
Excuse me, sir.
Yeah.
You can answer my question when you come back, actually, but I just wanted to ask you, some time ago you mentioned to us that IT is always changing, and that's actually one of the challenges that we face as professionals, that we always have to keep up to date. And I just wanted to ask you, in your opinion, maybe you can give us some information about most of the, highly demanded IT jobs. It's quite a wide spectrum of choices that we have, and to give us maybe to point us in the right direction of the ones that you figure. For example, I know cloud computing is on the rise, and you mentioned before that data science is also on the rise. So you can give us an example of some things that we should
The
try and
most
focus on.
topics right now in the world are AI. The most hot topics are AI, machine learning, and data science. Those are the three topics that are the top jobs right now in the world. And funny enough, they didn't exist 15 years ago. There was no job opportunity for AI. It was just a research area 10 years ago or 15 years ago. Of course, AI existed for quite a long time, but there wasn't very specific jobs to it. Now, in the companies, in the industry, it was more of a research area rather than anything else. Right now, there's a huge industry about AI development, and it's very well paid job. User experience researchers are getting very good jobs. Around their salary changes around $70,000 to $110,000 per year. So that is like the average salary. Software engineering is on the rise. There's quite a lot of environments right now being demanded, particularly Python has become the most popular language in the world right now since last year. And it's a very easy language but has quite a range of libraries about image processing, about machine learning, and so forth. So if I want to list these things down, I will say data science, machine learning, AI, are and the user experience designers are probably the top fields in our field right now. And it's incredibly competitive to get into hire business in this area because even when you send a resume, which is your CV, it's being scanned by an AI. It looks for keywords, and if you are not matching with the keywords, your CV is actually never being seen by even a human being in the first place. Imagine how competitive it is. I am under 1 minute right now, so I'm going to stop here. I'll re-invite you and see you guys in the next session. Hello guys, welcome to the second half of our course today. So in this one, since we described the project description and we briefly discussed about the job applications procedure and how important the assignments are about your degree, I will say let's move on with our lecture. So I assume everything is clear now about what you need to do as second part. One last thing that I like to discuss with you before moving on to my lecture is the final exam procedure that should be that would be, I guess, followed by the our universities. I am watching the news, and as of yesterday, the Higher Education Ministry in Turkey already explained that they are not opening the universities in Turkey this term, and no university will run official classroom education until the end of June. This means that the final exams should be online in Turkey. And the education ministry left this to the universities themselves to decide how they want to proceed this term. So they basically didn't want their hands to be dirty and left it to the universities. And I assume most universities in Turkey will do their final exams online. Now, we are Cyprus, we are not Turkey, but let's face the reality that a lot of things in this specific region, because of some political conflict, rely on Turkey. So whatever decision they take, probably our authorities will follow. So I am assuming, based on some politics, I am assuming that the final exams in the university this term are going to be online. Okay, this is my personal opinion, and I there is no official announcement yet. There is nothing, as far as I know, being announced by the Rectorate office. But I am assuming that I have strong idea that they will announce that very soon the final exams will be online. Now we have 50 percentage left, as you know, and if the circumstances are in the way that the final exam is going to be online, then I'm going to do a 50 percentage online exam. And that is going to be a multiple choice exam that you're going to participate on Moodle. Okay. If the circumstances are not going to change, you're going to take the 50 percentage as an exam on Moodle as a multiple choice exam. Okay. Right now, there is no official description, so it's very hard for me to say that I'm gonna do this or do that. But as I said, this is my personal opinion that very soon university is going to announce that the exams will be online this term. Now moving on, today we're gonna discuss about architectural design, which is kind of like very interconnected with system modeling. What you do here is that you, at the beginning of your system model, you pick up an architecture design that will help you out to model your system. So this is a decision you take concurrently with your system modeling, so that you can build up your model around this architectural design. Now, one of the things that you should really know that while we have different architectural models that you see in here, majority of the business outside, they actually combine this. They do not follow one particular one, but rather combine two or more models, particularly in big businesses, or even more so that different models coexist in the same system. Similar to how, for example, multiple languages are being used to support different environments. Like at the top of Facebook, we know there's some PHP and MySQL stuff, but we also know that there's quite a lot of C++ code going at the background to support the performance and AI and other issues. So it's not like Facebook, for example, is only written in PHP. There is no such thing. It is actually using different kind of systems, communicating with one another, different models, different script languages, so that they all come together and form Facebook, a system that you use every day. And the same thing is actually true for architectural design. While PHP is another language and C++, JavaScript are different languages or script environments, they are supposed to be different, but they can coexist in the same system doing different stuff. And architectural design is basically the same. So just because we have different kind of architecture, it's not like one system is this and the other system cannot be, the other one. So big systems like Facebook, Netflix, and even YouTube, they can exist with more than one architecture at a time. Okay. There is, of course, some differences between how you develop the software. For example, in agile development, architectural design is usually decided at an early development stage so that you can, build up the software around it. Whereas the architectural design is a step in requirements for a project requirement stage. It is not the very initial step, but it is something that you basically take a decision just before you pass into the modeling. So let's see, what is system architecture? A system architecture defines what connects, what is required, and how it should be done. So this is the connection in between the requirements and modeling. You know, in requirements, you define what should be done, and in the modeling, you decide how it should be done. Now, the connection in between the two is system architecture. So in requirements section, you define what to do. In system modeling, you draw a path regarding how to reach these requirements, and system architecture basically stands in between the two. Is it a separate step of modeling? Yes and no, because architecture basically will shape how you model the system, but it is also about how you're going to achieve to what you want to achieve. So I will say that it is the intersection in between your requirements and the modeling stage. Why are we learning system architecture after the system modeling then? If this is a system modeling step, like just before system modeling, why didn't we learn it before system modeling? There are two important reasons why I decided to move this chapter after system modeling, even though it is a step before system modeling. The first reason is that system design relies on UML, a de facto standard that is universally used now in software world. And if you do not know UML, many of the things that you decide on system architecture might not make sense to you. Such as there is the architecture called model view controller, and if you actually do not know how class diagrams work, about hiding data or object-oriented design, many of the things that forms model-driven development or model view controller, MVC as we call it, it might not make sense to you because you do not know the basic knowledge about class diagrams. So that is why it was very important for me to revise object-oriented patterns and some of the things that we need to mention in the modeling part before we actually go into the waters where we describe architecture. Also, to design a system architecture, you need to understand how data flows within a system. So a data flow diagram is technically drawn just after you decide the architecture. So I would say it is very intervened, very connected to system architecture. And if you do not know a data flow diagram, or now being replaced as the activity diagram, you might not understand a lot of things about system architecture, because essentially the whole point of system architecture is to show an abstract representation of how data flows throughout the system. In other words, what you decide to do in the data flow diagram or the activity diagram, as we call it right now, is the basis for system architecture. Now, in the old days, the data-driven modeling systems are developed through what we call as data flow diagrams. These are, as I mentioned several times in this course, are now replaced with activity diagram. Data flow diagrams was a big part of system architecture if you go 10 years ago or even more so, but now they're not as frequently used as the other diagrams. They are still a practice that can explain quite a lot of things in a system, and it might actually help you out to break down the systems, the data flow into models, into levels that can make more sense in certain circumstances. So even though data-driven modeling is not something that is used in the UML, it is still a practice that is followed, and I think you should know it. The UML does not support the current version, which is 2.5, does not support data flow diagrams. They were originally proposed and used for model data processing. The reason for this is DFDs focus on system functions and do not recognize system objects. Now, this is more about the functionality rather than the systems themselves. So it is more kind of like a more realistic approach rather than the abstract representation. So that is why they're not really a part of the UML specifications. The 2.5 version is released in 2012, and the previous version, which was 2.0, introduced activity diagrams, which are similar to data flow diagrams. So it's been some time that we are not using DFDs in the industry right now, but this doesn't mean that they are useless. They still have their own use. Activity diagrams replace DFDs in many aspects, showing the sequence processing in a system. However, DFDs are still used in the industry. Old habits die really hard and are frequently used to model data flow and interactions. With each passing year, I see less and less DFDs, even when you search for it. These used to be a very popular diagrams back in when I was a student. They were used quite a lot in the industry. Now we don't see their use that much because they have been replaced with new diagrams that makes more sense to development as the development evolved. But some of the things that DFD had originally, I really like it, such as leveling them, and could be quite useful in certain circumstances. Data flow diagrams, also called as DFDs, used to model the system's data processing, and they help understanding the definition of the system architecture. The data is displayed via data flow model diagrams, also called DFDs, and it's an end-to-end processing, which means there's a two-way communication usually in between the data. Now, one of the big differences between this diagram and the others that this one has levels. So it starts from level 0, which is the context diagram, which has only one process and multiple external entities. And each level, you divide the processes into more processes or more data storage units. So the external entity stays the same, but you divide the data processes. The processes themselves is driven into data banks, data storage units, or more processes. Data model diagrams show what kind of information you will put to and output from the system. So it's a two-way thing, and you can level them up. And with each level, the data model becomes more complex. Usually, the levels do not go beyond level 2 because if you go beyond level 2, then it becomes too realistic and very time-consuming to draw the diagrams. So the maximum level that you can actually reach usually is where you stop is level 2. Context diagrams, also known as level 0 diagrams, which has only one process node and multiple external entities. The diagram primarily defines the main process of the system. This is where you start drawing the DFDs. Every DFD starts with a context diagram, also called level 0. They are sometimes compared to use case diagrams. Context diagram and use case diagrams are similar, and they both show the main behavior of the system without identifying any kind of order or error. However, the use case diagram focuses on the actors, which are the entities, whereas the context diagram is more focused on the process itself. So the entire purpose of drawing the context diagram is to basically divide the process into sub-processes and show its relationship with other external entities. So when you draw a context diagram, you know that it's going to level up and you know that it's going to break down. Where use case diagrams, you do not break it. You just draw it and be done with it. There are quite a lot of limitations which basically resulted to abandon context diagrams in the industry. So we are also discussing about the historical perspective and more move into the UML specifications. So when we look at the context diagram, architecture models such as context models do not show the relationship between the other system in an environment. This is not something that particularly regards external entities as they stand outside the system. So whatever they are, they're still interacting with the system. The context diagram particularly does not consider the actors like the use case, which is what I basically said. And this can be counted as a limitation in terms of architecture because different entities can resolve different kind of interactions, and this diagram does not really consider that. And so I think this is one of the reasons why this diagram was kind of like abandoned and wasn't taken among the big five, which is the UML specifications. So a DFT representation starts by a context diagram, something I already mentioned, which is also called level 0 DFT. Once you have done it, you break down the process into more complicated structure where you show the relationships more and more with the external entities. And each division is only done on the process. So the processes can generate more processes or more data storage. DFT level 2 helps to understand how the system functions, and thus at this stage, software engineer can decide which architecture to use for their system. So another reason why we stop at level 2 is that now we have enough knowledge about how the system will function. Without coding a single line, we understand the relationship between external entities and flows. So we haven't done any coding, we just draw it. Now we have a good understanding on the system. We can decide which model or which architectures we want to use. So the entire purpose of drawing this diagram is actually deciding which architecture you want to use in your software. Before I move further, do you have any questions? Yes, you can talk, Tara. I'm going to lower your hand. Please talk.
Okay. Sorry, teacher. If possible, I have two questions. First, what are the drawbacks of data flow diagram that is lead to not can be used now? And the second one, we talk about the external entity. The number of external entity that participate in the data flow diagram, it is limited or depend on the complexity of the project?
The external entities are everything that can interact with your system. This can be a person, such as a customer. It can be an admin. It can be an unregistered member. It can be registered members. So they are actually roles of the system. But an external entity is not only limited about that. It's not only a human being. It can be a part of the system as well. Such as if you are designing a bank system, an ATM machine is an external entity because it is not something that exists in the system perhaps, but it is something that the customers are going to interact. So you need to consider some aspects of your software that the ATM machine is going to be a tool that they're going to interact. So any kind of hardware or any kind of interface that the customer is going to use, any kind of role that they're going to have on the system is an external entity. That is the definition of external entity. The roles on the system or interfaces that people are going to interact with. This is the definition of external entity. Now, the limitations of context diagram led to some historical perspectives that this diagram was abandoned among the UML. Now, before activity diagram was popularized, DFTs were being used, but people didn't like the idea that this had levels, so that each time they have to break them down, and it becomes more and more complex. And only in level 2 now you have enough information so that you can decide the architecture. I find that quite useful because I understand things much better if I go sequence by sequence, okay? So if I do one by one, it makes more sense to me. Okay. However, business do not think like that. For business, the faster the task is done, the better it is, because it is more profitable for them. Because the business changes in the industry, because how the software was developed, a very plan-driven approach is now something that we do not really look into. It is something that is frowned upon, something that is not ideal, okay? Because in today's industry, if you spend 2 years to develop a mobile application, basically by the time that you finish the mobile application, it's already gonna be something that people do not want anymore. Such as if you decide to develop a mobile application in for I don't know for public transport in Cyprus, because the circumstances change so fast. In 2 years, perhaps they will have hundreds of buses in Cyprus, and then they will basically address to the needs of the customers before you actually you release the software. Or 2 years ago, if you decided to develop this app and you just finish it right now and you release it in the middle of a pandemic, you're going to lose a lot of profit. The reason why the DFT diagrams are being lost is because they weren't fast enough to respond to the needs of the business. An activity diagram or all the other diagrams, they do not have levels. So I don't have to go into a deeper level and a deeper level to understand something. I can just draw it and be done with it and move to the next diagram, which is a faster way to deal with the business needs. So the answer to your question is because the requirements changed in the industry. 15 years ago, 10 years ago, let's say, you could have taken your time to develop an app, an application for the mobile phone could be developed in 1 year or 6 months. That's okay. Now, if you try to develop an app in 4 or 5 months, you can achieve that in a very good level, and anything above that, it's not very eligible to the companies right now. If you're going to take more time than 5 months to develop an app, it's not something that is worthy for them to invest in, because by the time that you finish it, maybe the requirements are going to change. So your app will be worthless. It will be too late to get into that industry to earn money. So to answer to your question is the world has changed, okay? We do not live in the same world as in 2002 anymore. Many of the things change. If this pandemic was, for example, happened in 20 years ago, it will not spread this fast because people weren't traveling as much as they are traveling right now 20 years ago, right? So that is the reason why DFDs are abandoned, because the requirements changed. But this does not mean that they are useless. They are still, you can still use them to understand your architecture, but it's just very time consuming for the business needs right now. Does that answer your question?
Okay, thank you very much.
Very good question, by the way.
Thank you.
So moving on, how to process the DFDs, we already done that. I am going to explain the notations on the DFDs. So we have 4 different important components that you need to be aware of when drawing DFDs. These are external entity, process, data store, and arrows. Arrows represent the data flow itself. And the notations are basically displayed in there. The interfaces are basically the external entities themselves. So similar to actors in the UCDs, these will represent a human or a subsystem component, such as an ATM machine, as I told you. External entities are where certain data comes from or goes to. They are represented as a rectangle in the DFD diagrams, and therefore software engineers usually draw external entities at the edge of the DFD rather than at the center. So basically the interfaces communicate with the process. The process themselves are the activities in the activity diagram. So this is how they transcend it. So this is the manipulation and transformation of data where that process being taken place. that can be decomposed each time when you go to a deeper level to define more details about your system. They are usually represented with round edge rectangles, and in the context diagram there's always at the center, and there's always one process, only one in the context diagram. Now in the level 1, you divide the context diagram process into multiple ones, and each time you can divide up to 10 to 15. If you have to draw more than 15 or 10, then you understand you have to go to a different level. Okay, that is how you can understand that you need to go to a different level. The data storage is where the data is stored. This used to be only files or database, but right now we have more data storage units, such as JSON files, such as XML files. They are all data storage units. Any kind of repository, Daniel mentioned cloud computing, those are now on the rise, as he said, and they can be the data store. Data flow itself are the interactions. Now, this shows that two important things should happen in the DFT. From an external entity to an external entity, there cannot be a data flow directly. They should either be connected to the processes because they both exist outside of the system. So this means that if an ATM machine is going to talk to a customer, there should be a data flow in between the two. And that should be done with a process. From a data storage to another data storage, there cannot be a direct data flow. And if there should be, then they should be merged. This means that they are basically should exist together. So you know how the data should flow. It should flow a data storage to an external entity or an external entity into the process. So the EFT can level up, something we already mentioned. Each time you understand this by breaking up the processes. Usually processes are the main units that are broken down when a DFT levels up. However, it is also possible that new data storages show when a DFT levels up. Each of these processes in a DFT diagram decompose and divided into sub-processes to reveal more details about the system. And each time you do that, you go to a different level. Usually, you break down this to 10 to 15 processes each time. If you're going to break more, this means that you have to go to a different level. The ideal breakdown in each level is between 5 to 15. I will say limited to 10 because then the diagram becomes too complex to follow. So that you need to basically divide it more and more to show more details. There are some level up rules that you need to follow if you're going to level up your DFT. When a DFT is leveled, no additional external entity should appear. That's rule number 1. If you're going to put another external entity, then you did design it in the wrong way. All external entities should be displayed in the context diagram, which means from the very start, you should decide what external entities you have. New data storages can be available and can be leveled as well. All data flows are automatically transferred to the new level. So you do not forget about the data flows in the previous level. They are still there and you should evaluate them. And as you go through them, they are transferred to the new level. That is the rule of the DFT. So I'm going to do 2 exercises in here. And we're going to touch to architectural patterns. So let's look at the first exercise. Because I'm not gonna do any more lecture tomorrow. I'm not gonna come to the online session tomorrow. I'm gonna come to next week. I'm gonna keep this lecture longer than usual. Sorry. So here is an exercise. Sorry. Here's an exercise. A retail clothing store in a mall can perform several sale transactions. Customers can pay at cashier point and get a receipt of their transactions. Having done this, the cashier point sends a management report to the store managers. Using the above scenario, list relevant data flows and draw a context diagram that represent the sale transaction at this store. So I color coded it so that you can basically tell which one is which. But it's very fair and very easy to basically draw when it is color coded. So when you read the scenario, you can see that several sale transactions can be done, which is a process. There is a transaction going on, and the transaction affect customers and the cashier point. The customer interact with the cashier point to perform the transaction. And because of this, some data happens, such as they can pay, they can get a receipt, they can send a management report. So when you look at this, the store managers and the customer themselves are external entities, which are indicated as yellow. The process itself is the sale transaction, and all the actions that the customer perform are basically listed in green as the data flow. Now I draw this diagram before, so if I go to Moodle, I think I unlocked it, so you will be able to see it. So if you go to the Moodle page, I already uploaded this DFT solution 1, and if you actually click on that, you will see the solution. You see that the customer is interacting with the sale transaction. This is the process because it has round edges. These are the external entities, customer, storage manager. And the interactions that the customer does are the data flows. Remember that interaction happens in the context diagram in between external entities and the process. There's only one process in the context diagram, which in this case, transaction. And the external entities are customer and store manager. This is a context diagram because it only has one process, and the only interactions are in between the process and external entities. I can immediately say it is a context diagram based on how the definition is done. So if someone asks you with a given scenario, what level is this DFT, what level at this DFT is, you can immediately say that it is at level 0. Now I'm running out of time again because each Zoom interview is limited with, each Zoom conference video is limited with 40 minutes. Before I run another session, I have 5 minutes. Do you have any questions? Did you understand the exercise, how it is done?
Yes.
So no questions then. Everything is clear, I guess. Very good. I'm gonna stop the conference here now, and please go back to BB once again. I will invite you to the third and the last part of today's lecture. I will keep it longer than usual so that we can perhaps finish this DFT exercise and move into the architectural patterns. So see you guys there. And welcome again to the third half of the lecture for today. I was doing the data flow diagram exercises, and I'm going to continue with that. In the second part, which is also uploaded to Moodle, you can see that there's another exercise that I have given you. We were supposed to solve these in the class together, but unfortunately the circumstances happen in a way that we can't right now. So I'm going to go through them and show the solutions to you. A gift shop or online gift system allows three types of users to use the system. These are guests, members, and admin. The guest can browse and search products on the list of products. While the guest can search and browse all of the products, they are not allowed to buy any products unless they register first. Guest becomes member when they register to the membership system. Membership needs systems basically requires a login interface, and when they log into the system successfully, they are verified by the system as a customer. Once this is done, the member can basically order products online, in this case gifts, from the product list. Furthermore, admin also needs to log into the membership system using the same interface, but this time they are verified as the administrator. Once this is done, admin can add, remove, and or modify products from the products list. Finally, the list of products stores and retrieves values of the product storage. So basically, the product storage is the data store. As you can see in this exercise, everything is color-coded again, and so you can immediately tell which interactions are happening as data flow, which are the external entities, and you can also see the processes. As you can see, there are multiple processes in the system, such as the list of products and the membership system. You can immediately say that this DFD is at least in level 1. There are further details that can be revealed, whether it is level 1 or level 2, but it is definitely not level 0. Because in level 0, we know that there is only one process, and in here, we can see that that is not the case. So this DFD, as given with the description, is at least in level 1. So if you want to draw this diagram, you can follow the color code and draw it. And the outcome will be something similar to what I'm going to show you right now. And we're going to go through it together. So going into the Moodle, I am going to go down and select the DFT solution. And this is something close to what you should get as if you draw this diagram. So let me just zoom in, and you can see in the diagram that there are different interfaces which are defined. These are the guest interface, the admin, and the members. You can also see the membership system, which is round edges. You see, it can be very confusing, but these are actually the square ones are external entities. The round edges ones are basically processes. And the interactions happen in between the external entities and also with the processes. What you can see in here that each guest can browse and search items from the list of products, so they can see it, but they're not allowed to buy anything unless they register as a member. If they want to buy something, they need to register to the membership system, which is done in here. Let me just mark it. Perhaps that would be better to show. So if the guest wants to basically do something with the system, as in ordering the products, they need to register to the system. They need to get basically verified. Once they attempt to log in, they get verified. This could be done in the opposite way, actually, because you log in, you then get verified. Once this is done, they can order the products with this system. So they can order and they can even get a response as order received and so forth. Remember that some of the details here can be left over because of the description, how the question is asked, such as in the question, it wasn't given that the products are approved, so that's not being shown here. Not every detail will be displayed in the VFD diagram because it's just as with the other diagrams, it's an abstract representation. Finally, the admin can add, remove, modify products, can be done separately or all together with the list of products. The ideal way to do this is basically to draw the diagram so that you can see how many interactions are being happened. So if I want to divide this system into units to assign it, I will basically give admin part to one person, the login part to another person. You see the login interface. And finally, the membership and the buy products part to another person. So to color code it, I will say this part is the membership. This part is where the admin is providing any details. So admin is being logged into the system and also adding the products. So that's going to be another part. And we done the login, we done the admin. What is left here is the buy products page, which is done from the membership. So we can do a third part to ordering the products. So as you can see from this diagram, there are three important parts. One of them is the guest being logged into the system and become a member. So there has to be a sign in and login form. The other one will be the admin. Basically, admin should log in just as with the guest. And then now they have to browse, add, remove products. And the final one is basically the members. This one will order the products itself. So all these interfaces will make up the system. Does it make sense how you can make use the DFDs and put them into use? Is this clear? Any questions? Okay, no questions, so I assume everything is perfectly fine, right? I'm going to move on then, since you do not have any questions. The architectural patterns. So this is the next subject that we're going to cover up in this video. Can you all hear my voice, by the way? Is it okay?
Yes, sir, I can hear your voice.
Cool. The architectural patterns are the next part that we need to cover. This part is basically come after you define the DFD. What you do here is that once the DFD is done, you have roughly an idea of how many parts you need to divide the system, how the interactions will happen, how the data flow can be broken down. And now you come to a decision which architecture you can follow up. It is important to recognize that no architecture is perfect. They all have their flaws, they all have their weaknesses and strong points. Just as with the agile development model, each model we had, they had strong points and they had weak points. So there is no such thing as the perfect architectural model, but many of the big companies out there, they try to combine these architectures to make their software more secure, more reliable, or support new features. So let's look at them. The patterns are a representation of a system that shows the sharing and the reuse of the knowledge, in this case, the data. The patterns itself are a description of the good design practice, which means they are tried somewhere in the history of software engineering, and they have been proven to be successful. Patterns are represented in using graphical representations, just as we did with all the other UML specifications using diagrams. Most architectural designs will be represented with block diagrams, which is basically just blocks showing how the architecture is being represented. There are different views in the architecture, which will consider different aspects. The book that you have, if you are reading the chapters, it divides this into 4 different categories. That's the logical architecture, the process, the development, and the physical one. Because of the close relationship between non-functional requirements and software architecture, the particular architectural style chosen depends on the non-functional requirement. So basically, it's all about how you support your non-functional requirements and how to represent the data flow. So after you define non-functional requirements, you do your functional requirements, you do your DFT, you decide on the architecture or architectures, then you do system modeling. This is the sequential order if you're going to do a plan-driven development. However, as I told you many times, this is not the only way to do it. You can actually take these decisions concurrently, which is basically the base for agile development. You know that in agile development, many decisions are being taken concurrently. So while you decide your architecture, you can also do design. Going down now, we have these views that the book mentioned. So let's read them through. The logical view is the abstraction in the system for the objects and object classes. Probably this is the most important one, because this is where the components of the system will be represented as interfaces, objects. A process view, basically how the interactions will happen. So this is basically the core idea behind modeling. The development view, the software is decomposed for development. It shows now the breakdown, the components, what we did in the DFT part. You know that I had a guest system, a membership system, an admin panel. So by drawing the diagram, I can break down into different components. So that provides the development view. And the physical view, it shows the hardware and software requirements. So by drawing that DFT diagram that I showed you, I achieve actually all these 4 models. There's a logical view here that shows how the system will function, right? It shows me a clear idea about the processes. We know how many processes are there now by drawing this diagram. We know how these interactions are happening, right? We know we have an idea of the members going into ordering products after being approved by the membership system and so forth. We have exactly an idea how this is going to be processed. We have the development view, which we can divide it into now different sections. I can assign, for example, Ravant to do the membership, Daniel to do the admin panel, and James to do the list of products, and Ahmed doing the members. So it divides the development view as well. And finally, if you have software or hardware requirements, you can also see them in this diagram, such as if we had a bank system, we would probably have an ATM machine here. So that machine is a requirement for us, and it's a physical view. It shows the system hardware and software components. Does it make sense? Block diagrams is a popular alternative to DFT now that DFTs are not officially recognized. Many people use block diagrams, but I really strongly suggest you to use DFTs if you want to show architecture. And that is what you're going to do in your project anyway. You're going to document the architectural patterns using a DFT if you want to do so. Main architectural patterns used in software engineering world are the model view controller, probably the most popular one, the layered architecture, which I always ask in my object-oriented programming classes, client-server architecture, probably Devrim Hoca covered this many times over in the network classes, repository architecture, which is the cloud computing Daniel mentioned today, and the pipe and filter architecture, which are usually the architecture for Linux-based embedded systems. These are not the only ones that are available. If you look for architectural patterns in software engineering, you will probably run into much more, but these are the most popular ones that is followed in the industry. Like I said, we theoretically assume that if you use model view controller, that is the architecture that you use in your software, but this is not true anymore. Unfortunately, the systems have become so distributed, so wide, so big nowadays that the whole world is basically connecting to them. Hence why one architecture is not enough to support that big systems, such as Netflix is basically a client-server architecture, but it is a distributed system. So it has repository, it has layered, it has model view controller. So it is more than one architecture at a time because it's such a big system. It is, at its core, it's a distributed system. So I would say it's a client and server architecture. But because of its features nowadays, it is supported by many different architectures. This is probably the most common one that you will run into. Model view controller is a very, very popular architecture, and MVC is something often mentioned in software engineering world. And it means that you separate how data is stored from how it is represented. That is actually the definition of model view controller. The way that you store data has nothing to do with how you display it. The core idea behind MVC has become really popularized with the rise of the smartphones. Nowadays, you can design a website and you have absolutely no control how people are going to access to it. 20 years ago, you could design a website and you would know that everyone is going to access it from a computer, and that's it. Computer was the main way to connect to the internet. Nowadays, this is not true. You can connect to a website from a telephone, from a smartphone. You can connect to a website from a laptop, from a tablet device, from even GPS of some equipment in the cars can now be connected to the internet. So we have absolutely no control how people are going to connect to the website you design. So this is why you have to keep in mind that your design on the front side must be responsive, must respond to the environment that the website is being accessed. It must recognize whether the access is coming from a computer or a tablet device or a smartphone, so that you can make the design responsive to fit into that specific resolution, so that the website will not look awkward, or the text will still be looking or the images still be looking nice enough to fit to the screen. For this reason, with the rise of the smartphone devices, this architecture became very popularized because you store the data the same way in the background, but how you display it is basically depend on the machine, on how it is accessed. And hence why we call it model view controller. The view actually being controlled, and it is separate from the model itself. That is the core idea behind MVC. Majority of the systems in the software world, particularly the websites that I mentioned, if you're going to run an e-commerce business, for example, they run on an MVC system, which means the model, the view, and the controller are separate things. The way that you represent data is different than how it is stored. The system is structured in three logical components that interact with one another. Model manages the system data. View component defines and manages how data is presented. And controllers manage the interactions. Model view controller, also called MVC, separate presentation and interaction from the system data. The system is structured into 3 logical units, and they are, although associated, completely different from one another. So, for example, a mouse click on the computer can be recognized in a smart device as a touch action, because we do not have a mouse on a smartphone, we have our fingers touching to the screen. So the differentiation, although the interaction is recognized in the same way, the activity is different, but the way that we respond to it will change according to from which device the interaction is being done. There are specific advantages to this model, such as you have the independency of how you represent the data and vice versa. You support presentation of the same data in different ways, which can adapt to the devices that the website or whatever you design is being accessed, and adapt so that you will have different kind of views for each environment. However, it involves additional code. Like 10, 20 years ago, you didn't have to put into your CSS file of whether it is going to be a mobile access or whether it's going to be a computer access, whether this resolution and that resolution. You didn't have to consider any of these aspects. You knew that it was going to be from a computer, and it just, designing it in HTML straight away could be enough. Nowadays, that's not the circumstance. I cannot imagine a website not being supported by CSS or JavaScript anymore. That's like impossible nowadays. So it involves additional code. A front end designer used to know only about HTML and graphical design 20 years ago. Now, if you're going to hire someone to work on the front end as the user interface of a software or a website, they need to understand JavaScript, they need to understand HTML, CSS, and even other technologies in order to make sure that they can come up with a nice model view controller. Any questions about the organization of model view controller? I assume this is something you already should be familiar with, at least theoretically, because model view controller is now very much popular. Like, it's not even mentioned in job interviews. Like, it's automatically assumed that you should know this. Okay.
Especially in frameworks, if I'm not wrong, sir. Especially in frameworks.
Yeah, it's not even mentioned in job interviews anymore. Like, they automatically assume that you know the stuff, and if you don't know it, what are you doing there? Like, that's like a norm now. So this architecture is something that you should really, really know. Okay. So since you don't have any questions, I'm going to move on. This is how a website can basically support an MVC pattern. The browser basically access to the controller, which then access to the model and generates a view for you based on the browser, which is the device that you access. There are many reasons, of course, why we use MVC. We already discussed this part, so it's basically repeating what I said about the advantages and disadvantages. So I'm going to move on to the next layer. The next layer we're going to cover up is the layered architecture. The layered architecture is something that I really encourage in my object-oriented classes. It is somehow very similar to the MVC, but the idea here is not to generate the view, not to separate the view from how the data is stored, but the idea is to separate the business tier from the data tier. That is the purpose of the layered architecture. You want to separate your logical decision step, which is your business tier, from the data tier, and also from the user interface, so that this can be handled separately. You do this architecture because of the code reasons, to make the program more maintainable. The MVC is done basically for the clients, because you want your clients to see the interface differently on different devices. The layered architecture, however, done because of the developers, to make the development procedure more sustainable, more maintainable than before. If you're going to confuse your user interface with the business tire, and they all going to be a mixed bunch in the program, later, if you want to change your interface and make it with modern graphics and more responsive, it's going to be very difficult for you, because your business tire will be intervened with the layered user interface. So you've got to do a separation. It's like keeping your basically, if you do not do the layered architecture, it means that you keep all of your dirty clothes with the new fresh ones. And eventually you're going to mix up which one is clean and which one is dirty. So it is something that we do to separate a distinction between which clothes are dirty, which are clean, so that we can always access to the clean clothes when we want, and when we want to do our laundry, we can always access to the dirty ones. That is basically the reason why we do the layered architecture. And there are 4 layers in the layered architecture. These are user interface, business logic, management and validation, which is basically kind of like the quality assurance step of it, and finally persistency, where the database is or other layer of data will stand. I would say, however, despite that I recognize 4 different steps exist, and the book also mentions this, I would prefer to keep it in 3 steps rather than 4, because as you define more and more layers, the program becomes more complicated, and more importantly, it slows down. Okay, that is the problem. The more layer you add to the environment, the more performance-wise you suffer. So technically, if you copy paste everything in one file, rather than keeping them in 3 different files, the program that runs everything in one file is probably faster than running 3 files at the same time. That is true, but also it also means that the one file that includes all the code is probably much messier than dividing into 3 files. So it all comes back to creating a balance in between. You want your dirty clothes away from your clean ones, but you don't want to go and separate each and every one of the categories differently, because then it will complicate things. Imagine that you separated your dirty clothes and clean clothes, then you separate in between the whites, the colorful ones, the blacks, the shirts, the trousers, then you will have so many categories to deal with, and it will go into a mess. So that is the core of the layered architecture. We want to keep different one from one another, so that we will ensure that we're going to access to the clean clothes when we need, but we don't want to go over the top so that we can mess up so many categories and it becomes too complicated. Okay, that is why despite the fact that most resources will suggest you 4 layers, I will say that stick with 3. Keep the user interface and authentication together. Keep the business logic as the middle tier. And finally, the database as the last tier. So 3 levels probably would work better than 4. There are 3 variations of the layered architecture that I see. These are the two-tiered architecture, which is basically just a separation between user interface and database, something that I do not really recommend at this age. 20 years ago, once again, you can use this. I did use it, and it was very useful during my master thesis, for example. I used a two-tiered architecture, and I really got high marks at the time. But that was 20 years ago, and the times have changed. You could use three-tier architecture, which is the ideal one that I suggest. It's not going over the top, but still keeping things differently. Or you could use a four-layer if you want, okay? There are certain advantages and disadvantages with this architecture, like with any architecture out there. For example, each layer is individual, so it's much more maintainable now that if you want to address a change in the user interface, this is not going to affect your data layer or the logic layer. Consistency, you know that you can now replace layers without basically interrupting other processes. Replacement of layers, as long as the interface is maintained, is possible. And of course, because the program is divided into multiple layers, it becomes automatically more secure. However, it comes with disadvantages. Because of the security, now you sacrifice some performance. There are performance problems that are known with the layered architecture. The more layer you add, the more it becomes complicated. So the more time the computer processes, and hence the program slows down. Also, with each layer, there is a new complexity added into the picture. So you need to basically consider that as well. Now, it's been way over 2 hours that we have been doing. I want to stop in here. In the next lecture, I want to discuss about more architectures. I think we did quite a lot for today. So in the next lecture, I'm going to talk about more architecture, such as client server, repository, pipe and filter architecture, and also, provide you a summary of these at the end and finish this chapter. I do believe we have done quite a lot for today, isn't it? Do you have any questions? Is everything clear? Is there anything you did not understand and you want to discuss?
No, thank you, sir. I don't have any questions.
Okay, very good. Like I said, I'm not going to do any more lectures on Wednesdays. I will dedicate my time particularly on my graduation projects. I have 3 graduation projects this year, and they need some help. I have 3 master's students and 1 PhD. I want to help them a bit because they are suffering. So I am not going to do any more lectures on Wednesdays, but I will continue my lectures on Tuesdays, every Tuesday. And I'll try to keep it longer than usual, like today was longer, if you have realized, so that we can do more lectures and we can finish it on time. After this subject, I think I have 1 more chapter and I'll be done with my course. And as I learn from the university about the final exam procedure, I will share this with you model. As always, I recorded all of these sessions and I will upload them to Moodle. So if you want to go and rewatch this lecture, you will be able to do so from the class archive. Once again, thank you for coming to my class. I really enjoy teaching you. I hope you also enjoy these lectures. And feel free to talk to me during interactive sessions. Take care of yourself, guys. I'll see you next week.
Have a nice day, sir.
Bye.